Okay, everyone. So we're going to wrap up the material on our next test with this video. This is a really easy bunch of sections. We do just a little of 9-4, 9-5, 9-6, and 9-7. We wrap it up. We'll do a little bit of that. And then I understand I forgot to do the last part of action, so I'll give you those answers to the concepts and vocab in a little bit. But look at your 9-4, 9-5, 9-6, 9-7. The packet is on Blackboard, and if you, again, I always say this, but if you don't have it printed, it's not a big deal. You're just going to take some notes. So metric system is really cool because it's so easy to go back and forth between the various units. You know, for us to go between feet and inches, it takes a little bit of time, and we saw the fraction work that we had to do in order to do that. Oh, with the metric system, it's super easy, mainly because of this chart and of this little saying that people use to be able to dance back and forth between the different units of measurements. All right, so what I want you to notice, and I know you've all heard of a milliliter or a millimeter or a milligram, right? I know you've heard of milli, and I know you've heard of centimeters. Deci is not so popular, but I know you've heard of the milli, the centi, and the deci. All right, there's 1,000 millimeters in a meter, 100 centimeters in a meter, and when I say a meter, I mean this base. So this base can take the form of various types of bases depending on whether you're looking at length, whether you're looking at weight, or whether you're looking at like volume in terms of capacity, right? So all of the ones that end with the i's are smaller than the base, the deci, the centi, and the milli, because sometimes people get confused between the deca and the deci. But the deci hangs out with the centi and the milli, all right? And then you've got your base. The base can be meters, it can be grams, or it can be liters, right here. And then we're looking at the big fellas, the deca, the hecto, and the kilo. Like I know you've heard of a kilometer, a kilometer, a kilometer. So that would be 1,000 meters. So we'll talk about these a little bit more, but what I want you to do is I want you to grasp these letters, because we're going to use this chart that King Henry died by drinking chocolate milk. We're going to use this chart to be able to go back and forth between these types of measurements. Okay, so kilo means 1,000, and you see the kilo goes with the K. Hecto means 100. Hecto gets matched with Henry. Deca means take that base and multiply it by 10. Okay, so if I had meters and I put 10 meters together, that's also called a decameter. Okay, and then base is by, deci is drinking, centi is chocolate, and milli is milk. All right, so let's look at a couple of the units of length and see if we can understand how to use this chart to dance back and forth between our measurements. And I know we've talked about this before. If you look at a AAA battery in the back of your calculator, that is about the length of a centimeter. Some people also compare it to your pinky nail. The thickness of a credit card is a millimeter. And this tower in Japan is really tall. We usually think about a kilometer and a mile, but a kilometer is a little over half of a mile. All right. So we want to convert 102,300 millimeters to decameters. So we're going to use this chart. So the start is the original units you're given. So we're given millimeters. So I'm going to start here on the M. See my pen up here? So this is start. And then I'm going to count how many words I have to get to deca. You remember this is the deci, centi, milli, so deca would be over here at die. So start. I want you to say start, not one. Start. 1, 2, 3, 4. Do you see from the start to get to deca, I'd have to go start 1, 2, 3, 4 to the left. that means I'm going to move my decimal 4 shifts to the left. So if you don't see your decimal, you know it's at the end of the number, and I'm going to go 1, 2, 3, 4. Plant it. So that's going to be 10.23 decameters. Does that make sense? Okay, we're going to, every single section is basically the same thing. All right, so we're going to go from kilometers to meters. All right, so we're going to start here at kilometers because that's our starting value. So this is the start. And remember, the base is either meters, grams, or liters. So I want to go to the base to get to meters. So start, 1, 2, 3 to the right. So it's 3 to the right. So now I have to move my decimal 3 places to the right. 1, 2, 3. So 0.045 kilometers is 45 meters. I mean, some people say you could just, instead of decimal dancing it, you could take it and multiply it by 1,000 to get to the base, but I just think it's so much easier to just use this chart and move your decimal back and forth. But 0.045 times 1,000 would also give you 45. All right, let's try this one. 125 centimeters to meters. So 125 centimeters. So I'm going to start here at chocolate. So this is my start, and my base is my meters. So start, 1, 2. So 2 to the left. Okay? So here's my decimal. 1, 2 to the left. So 125 centimeters is the same as 1.25 meters. All right, why don't you pause it and try to do this one. Remember, meters is as your base. So pause it and see if you can go from meters to millimeters. All right, here's my base, here's my meters. So here's my start. 1, 2, 3. So it's 3 to the right. Okay. So if I go 1, 2, 3 and plant my new decimal, remember, if we have that extra loop, we have to fill it in. I don't want 2 decimals in my number, so you get rid of that first one, and this will be 450 millimeters. How'd you do? You doing okay? I need this Henry died by drinking chocolate milk to be handy, all right? So at the top of the next page, we have just some thinker questions. Why don't you pause the video and see if you can make some sense of those, and then come back and see what you can think. We'll do them together, okay? All right, you ready? I'm going to fold my paper so I have my King Henry died by drinking chocolate milk. And this will be on your formula sheet. You don't have to memorize that King Henry died by drinking chocolate milk. All right, so when we have this 3.4 meter rope is attached to a 5.8 meter rope, they're tied, but when you make the knot, you lose some of the rope, right? It's not going to be 3.4 plus 5.8. It's going to be that minus whatever you lose. So this is my 3.4 meters, and we're going to add 5.8 meters, but then they said you lose 8 centimeters. So this is great as long as we can convert that centimeters to meters, because they wanted to know the length in meters. All right, so let's convert it, and then we'll add it up. So if I'm starting with centimeters, I want to change that to meters. If I'm starting with centimeters, meters is my base. So start, 1, 2 to the left. So 8 centimeters, here's my decimal, 1, 2 to the left. That's what that is going to equal in meters. So we're going to take this, we're going to add this, and then we're going to subtract 0.08 meters. So let's see what that would equal if we pull out my calculator. There we go. 3.4 plus 5.8 minus 0.08. Looks like the length of the rope will be a little over 9 meters long. How'd you guys do? Does that make sense? All right, let's try the other ones. You ready? So this one we could do it in 2 parts. It didn't say how much thicker the ice, so we can answer the question in centimeters, or we can answer the question in millimeters. So that says that it is 5.33 centimeters thick, and it's only safe to go on it if it's 80 millimeters thick. So if we convert everything to centimeters, let's convert the 80 millimeters to centimeters. Millimeters is what in centimeters? Okay, so millis here. So you have to start and then go 1 to the left. So 80 millimeters will be 8 centimeters. So it needs to be 8 centimeters thick. And right now it's 5.33 centimeters thick. So how much more thick does that ice need to be in order for it to be safe? Did you guys get 2.67 centimeters? That's how much more it has to freeze in centimeters. But if you said, oh, I thought about it in millimeters. Okay, well, it needs to be 80 millimeters thick. Right now it's 5.33 centimeters. So to convert this to meters, or millimeters, we're starting here at centimeters, and we would go 1 to the right. So if I move 1 to the right, that's going to be 53.3 millimeters. Right? So this is how much it is in millimeters. This is how much it needs to be in order to be safe. So let's subtract, and you should get 26.7 millimeters left in order for that free to be safe. Okay, and then the last one talks about the Chemung River. And it says the sediment bottom of the river right here. So it says it's normally 14 centimeters thick, but a recent flood washed away 22 millimeters, and they want to have it in centimeters. 22 millimeters got washed away. So if this is millimeters, I need to go to the left 1 spot to have it be centimeters. So does it make sense that that's 2.2 centimeters? So it says the sediment in the bottom is normally 14 centimeters thick, but 2.2 centimeters got washed away. All right? So let's figure out how much got washed away. 2.2 centimeters got washed away. This is how many centimeters are left. Okay? Those aren't too bad. Those are off of my math lab. The questions like that, they're pretty similar. So that is length. But I'm telling you, nothing as much is different if you're going back and forth with units of weight and mass. I just wanted to show you. So the mass of a large paper clip is a gram, and a liter of water. You guys know what 2 liters looks like, but half of that is almost like a kilo. That's what a kilogram would weigh. And a milligram is really, really little. They said it's like 3 to 5 grains of table salt. That's really teeny, is a milligram. And then I thought this was something that I took a picture of, ibuprofen. And that's about 200 milligrams. Maybe that should make some sense when we talk about milligrams. All right, you ready? So let's get our King Henry died by drinking chocolate milk out and do some conversions. Excuse me. All right, here we go. Oh, and I had a box of crackers in the cupboard, and I was like, oh, those are 403 grams for a box of crackers. Oh, and this one too. If a kilogram excuse me, a kilogram is a little over 2 pounds. Okay? So I weigh about 60 kilograms because I'm, 60 times 2, 120, but it's a little over 2 pounds, so I weigh more than 120. So it's a little over 120. It's like a normal adult woman. I'm kind of short, so I don't know if that would be a good base, but I weigh between 120 and 130 pounds. All right, here we go. You ready? So a kilogram to a decigram. All right, here we go. I'm sure you guys really didn't care about how much I weigh, but I'm kind of short. So, there's ranges of weights for adult males and females. I'm on the shorter side, so don't go by my weight for normal. Anyway, you ready? So, kilogram to decigrams. So here's a kilogram. That would be the K. And we're going to go over to deci. Now, K all the way over to this D. Ready? So kilogram, start. 1, 2, 3, 4 to the right. Right? Start. 1, 2, 3, 4 to the right. Okay. So 1, 2, 3, 4. Do you see there's no difference on how you solve these, whether you're doing with lengths or, in this case, weight? All right, 1,000 milligrams to grams. Okay, here's milligrams. Your base is grams now. Okay, do you see the base? Grams. So start. 1, 2, 3 to the right to get to the base. 1, 2, 3 to the right to get to the base. Do you see that? So 1,000 milligrams to grams, you go from milli to your base. Start. 1, 2, 3 to the left. 1, 2, 3 to the left. Okay, you ready? Let's try this one. It says a small can of Planters sunflower seeds weigh 177 grams. Okay. If each can contains 6 servings, find the weight of 1 serving. Right, well, this is bad. This is probably back division. So if this is the small can, it's got 6 servings. So it says find the weight of 1 serving. If they want it in grams, we're just going to divide, right? If they want it in grams, we just divide. So 29.5 grams. It was just a division problem. Okay, let's try this one. Sudafed is a decongestant. Sounds like that's what I need right now. That comes in 2 strengths. Regular is 60 milligrams. And extra strength is 0.09 grams. So how much extra strength medication will there be in that extra strength tablets in milligrams? So how many more milligrams does this have compared to this one? Well, we got to get this in milligrams. So here's my base. Okay, it's in grams, and I want to go to milli because they said they want it in milligrams. Mg means milligrams. So base, so start. 1, 2, 3 to the right. Okay, so start. 1, 2, 3 to the right. So it looks like 0.09 grams equals 90 milligrams. So if we're comparing 90 milligrams to 60 milligrams, it looks like the extra strength tablet has 30 milligrams more medication. All right, last one. Okay, so they talked about these Quaker oatmeals. 12 boxes weighs that much. But of course, when they talk about the weight, it's the food and the box. So the box has this packaging material. So they want to know actually how much oatmeal are you getting in kilograms. All right. So the boxes weigh 26 grams. Okay. So the boxes weigh 26 grams each. So let's convert that to kilogram. Okay? So grams is my base, right? So here's my base. So to go from grams to kilogram, I'm going to move my decimal to the left. Here's the start. 1, 2, 3 to the left. So here's my grams. I start 1, 2, 3 to the left. Okay. So then the boxes weigh 0.026 kilograms each. Same thing, right? So we have 12 of them. It says there's 12 of them. So let's do 12 times 0.026 to see how much the boxes weigh. So it looks like they weigh 0.312 kilograms. Is that what you guys got? I wish we were together so we could fact check this. All right. So this is how much the boxes weigh, and this is how much it says that everything weighs, the oatmeal and the boxes. So then to get to how much oatmeal is actually in there, let's subtract the weight of the oatmeal in the boxes. We'll take away the weight of the boxes, and then what we have left is going to be just the oatmeal. So did you guys get 6.12? So 6.12 kilograms of oats. How do we do? Does that make sense? All right. I'm telling you, there's nothing really a lot different among all these sections. So the last one is just some volume. And it's still, let me pull my chart out, it's still King Henry died by drinking chocolate milk. So we know what a liter is, right? Because Cheryl was drinking the 2 liters. Remember, she had the 2-liter bottles of soda. So half of that would be 1 liter. And then the amount of milk shown is 1 milliliter. So that's like a little teaspoon of water. A milliliter is really small, or a teaspoon of milk. But can you see the King Henry died? There's my liters. That's my base. Drinking chocolate milk. And I said, you remember, we said that sodas are often packed in 2-liter bottles. So everyone kind of has a sense of what a liter is. All right. I think you guys should pause the video and try these. I bet you could go, with our chart, you could easily go from deciliters to milli, centi to hecto, and milliliters to liters. Why don't you turn it off and just give it a try, okay? See how you do. And then come back and join us. All right. All right, let's do it. I'm hoping you turned it off and tried it. So deci is right here. Remember all the I's, deci, centi, milli. So deci's here. And we want to go, so start 1, 2 to the right. So here's my start. And I want to go 1, 2 to the right. So it looks like there's 1,200 milliliters in 12 deciliters. All right, let's try centi to hecto. Okay, so here's my C, and hecto's over here. So start 1, 2, 3, 4 to the left. So here's my start, 1, 2, 3, 4 to the left. And then you plant your decimal. You don't need 2 decimals, you just plant it. If you don't want to write those zeros, you don't have to. But there's my hectoliters. So 2,500 centiliters is 0.25 hectoliters. All right, let's try one more. We have milliliters to liters. Remember, the base is my liters. So I'm starting with the milli. 1, 2, 3. Start with the milli. 1, 2, 3 to the left to get to the base. So 1, 2, 3 to the left to get to the base. Looks like it's going to be 3.21 liters. And then with like on my, they want you to do it both ways. Find your answer in milliliters, and then maybe a different way and find it in liters. So if I wanted to add these up in milliliters, I'm going to take my 2,400 milliliters, and then I'm going to change 8.9 liters to milliliters. All right, so let's go ahead and do that. I'm going to do it right here. 8.9. So here's my base, because liters is the base. To get to milli, we're going to go start 1, 2, 3 to the right. So start 1, 2, 3 to the right, and then fill it in with zeros. So this is what this would look like if they said add these up in milliliters, right? So it looks like 11,300 milliliters. Okay, how about this guy? They said add it all in liters. All right, so we're going to have 8.9 liters plus, let's come up here and convert 2,400 milliliters to liters. So milli is milk, and we're going to go start 1, 2, 3 to the left. Start 1, 2, 3 to the left. So it'll be 2.4 liters, and if we add those up, looks like we're going to get 11.3 liters. So that's not hard. You just have to be careful what they're asking, right? So you're going in the right direction. That's the only little trick. All right? So let's practice with a little bit of conversion review. I thought we all needed the review. So I gave you this little chart. Okay? I gave you this chart. Now, if you should come across something it's not on the chart, it's not it's not the end of the world. What you should do on My Math Lab is click on the bottom ribbon, and it will give you the conversion that you'll need. Okay, so this is from cups to fluid ounces, and that's on the old chart that we had. So if you have the conversion chart, it's on Blackboard. Cheryl asked if I would print out one that had all that on. So look at the one on Blackboard or your old notes, and you'll see that cups to fluid ounces, there's 8. Okay, so 1 cup has 8 fluid ounces in it. Okay, so we have 3 cups that are poured into 6 dessert dishes. How many fluid ounces of Jell-O are in each dish? Okay, so what do you think? So we have 3 cups, so that means if 1 cup is 8 fluid ounces, then how many would 3 be? Then 3 cups would equal 3 times 8 fluid ounces. So we have 24 fluid ounces altogether. Okay, and this I just got off a chart when I looked in my notes. And so we're going to take this 24 fluid ounces and pour it into 6 dessert dishes. So does it make sense that 24 divided by 6 dishes, there's going to be 4 fluid ounces in each dish? Does that make sense? I hope it does. Okay, let's practice with some other stuff here. Are you ready? It says that the liver is the largest internal organ. Didn't know that. It weighs 3.5 pounds in a grown man. Convert this weight to kilograms. So I thought this would be good practice. Ready? So this is what I'm starting with. Remember, this is going back from US to back and forth between US and metric. I want to get rid of pounds and be left with kilograms. Okay, so go ahead and look at the weight. I see. I'm going to use one right here. It's the first one. You could use this one as well. I'm just going to use the first one that I see. So 1 kilogram has 2.20 pounds. So then I'm going to pull out my calculator. I'm going to multiply these two fractions together. And then, I'm not sure what they want you to round it to. Let's just round it to 2 decimals. 1.59 kilograms. You remember how to do these? I thought this would be a nice little review. All right, now they talk about compact discs are 12 centimeters in diameter. Okay, this is what we're given. And they say convert this length to inches. Okay, so here's my centimeters to inches. Do you see that? So I want to get rid of centimeters and be left with inches. Right, so I have to put centimeters on the bottom so they'll cancel, and then I filled in. So 2.54 centimeters are in 1 inch. All right, ready? So we've got 12 over 1. That's not right. 12 over 1 times 1 over 2.54. Did you guys get about 4 point, what do they want? Oh, round your answer to 2 decimals. So 4.72, right? We want to keep that 2. We don't want to make it higher because that 4 says keep it. How we doing? We doing okay? All right, and I thought this was an interesting one. I got this off my math lab. So Australia, which is a big feat, converted the metric system. They converted to the metric system in 1973. It must have been a huge accomplishment to change. Think of all of our marker signs and all of our things that we do in school are in feet. It would be a pretty big deal to have a whole country do that. So it says in that year, 4 postage stamps were issued to publicize this conversion. One such stamp is shown. So it says, let's check the math on the stamp by converting 7 fluid ounces to milliliters. Let's convert 7 fluid ounces to milliliters. Okay, so I want to get rid of fluid ounces and I want to be left with milliliters. Okay, so look up. Its capacity. Do you see it right here? Fluid ounces to milliliters. So in 1 fluid ounce, we're going to have 29.57 milliliters. Now, if you don't want to use the fraction for this one, you don't have to because you just have ones in the bottom. But how'd they do? Yeah, I'd say they did pretty well. What do you think? I would say that's pretty close to 200 milliliters. Not quite sure why they didn't say 207, but they did okay. So 206.99, and then they said round to the nearest 100. So do I keep 2 or make it? Because that's my 100 spot. I would keep it, and then everything else would become zeros. Right to the 100, they were spot on. Okay? And then the last little bit was kind of an official review for the metric, going back and forth between Fahrenheit and Celsius, US and metric and temperature. We've already done this, but I thought it would be worth doing it again. So it says we're visiting Canada, and the television says it's 22 degrees Celsius out. So what do we need to wear? All right, well, these are two formulas that if you're given Celsius, you can easily figure out Fahrenheit. If you want to use the fraction or if you want to use the decimal, do you see it doesn't matter that 9 over 5 is 1.8. So I'm assuming you all are going to want to use the decimal. So I'll do this one. If they said it's 22 degrees out, pull out your calculator. What is that temperature in Fahrenheit? What do you think? Do we need a winter hat? I would say no. I would love a day where it was 22 degrees Celsius outside. Says I'm visiting Canada and I don't feel well and I take the temperature, but since I'm in Canada, the temperature says 37 degrees Celsius. So should we call the doctor? I mean, I hope that's not Fahrenheit or you are really cold. So do we call the doctor? What's my temperature in Fahrenheit? Nope, that's normal. 98.6 is spot on. So we don't need to call the doctor, right? We don't have a fever. Okay, and then I thought this was interesting. It says the boiling point of water is 212 degrees Fahrenheit. So here's the formula if you want to go from Fahrenheit to Celsius. So what is the boiling point of Celsius? You guys might already know this. So let's see what the boiling point of Celsius is. So we've got 5 over 9. See how I use my fraction key? And then my parentheses. 212 minus 32. It's 100 degrees. So if it's boiling at 212 degrees Fahrenheit, that's the same thing as 100 degrees Celsius. I just thought that was interesting. I like how those formulas work. All right, I'm hoping that my math is an easy one. Have your King Henry died by drinking chocolate milk very handy, right? And that's not something you have to memorize. That's so on your sheet for your test on chapter 5. All right? We talk to you soon. I hope everyone's doing really well. All right? Take care.